For our 9.2 practice, you need to do numbers 10 through 15 on page 283, and then you get to choose any 7 problems from 285. So I'm going to do a few of these with you and then let you try the other ones on your own. So for 283, it wants us to, let me get a pen here, circle whether we have to add or subtract to solve. So not whether the problem tells add or subtract, but what we have to do to get the variable alone, and then we'll solve it. So number 10 here says 8 plus x equals 42. So I want to get x alone, so this is a positive 8. So I need to subtract 8. So I'm going to subtract, and then I need to show my proof that I'm taking away 8 on both sides. So 8 minus 8 cancels out to 0. So I'm left with x equals 42 minus 8. I'm going to let you finish that part there. Number 11, we have w minus 61. So I'm at negative 61, so to get to 0, I need to add 61. So I'm going to add 61 to this side. I'm going to add 61 to this side. So if I have a negative 61 and I add 61, I've canceled it out to 0. So w equals 14 plus 61. If you go ahead and add those together, you will get the value of w. Okay, and I'm also going to do number 15 with you. So it says, I don't know why it's so blurry, c plus 5 ninths equals 8 ninths. So this is an addition problem. So I have positive 5 ninths, so I need to take that away. So I'm going to subtract 5 ninths, so 5 ninths minus 5 ninths cancels out. And then I'm going to minus 5 ninths on this side. So over here, I'm left with c equals, so my denominator, what a nice problem they made for us, are already the same. So I don't have to do anything to that. 8 minus 5 is 3. And my denominator stays the same, 3 ninths, and we could make that an even better answer, and we could simplify it. So can you think of something that goes into 3 and 9 and divide both of those and see if you can simplify 3 ninths? So what can you divide 3 by and 9 by? Same number, so divide them both, same number. Okay, so go ahead and finish all of 10 through 15. And then we're going to work on page 285. So for page 285, you have to choose any 7 problems. So I've just picked a few. I don't even know if it's 7, but I think you can do most of them. So let's look at this one here. It says 35 equals y minus 6. So lots of times we're used to seeing the answer at the end. This equal sign doesn't mean solve it. It just means these are the same. This side and this side are balanced. So I really could even say like 20 plus 15 equals y minus 6. So it doesn't always just have to be one thing on that side of the equation. So they can flip. You can put the answer in the front or the back or whatever it is. Okay, so we want to get y by itself here. So it doesn't matter which side it's on, we still want to get it by itself. Minus 6, so I have negative 6, so I need to cancel it out to 0. So I do the opposite, which is to add 6. So that side cancels out, and now I need to add 6 on this side. So now I can see that y equals 35 plus 6 will tell you your answer. So one thing you have to do is you have to make sure that you show this proof. I know that that is a problem a lot of you can do in your head. That is not the point. The point is that we are practicing canceling one side out and doing it to the other side to keep our equation balanced. Okay, number 4 says that Mary compares the heights of 2 trees. So we've got this tree is, well, no, that's not what that says. Okay, let me look over here. This tree is 12. Oh my gosh. Numbers are hard this morning. Okay. This tree here is 45 feet. And then this tree is 12 more. So I can see from here to here is 12. So we've got 45 and then 12 more. So we do not know the height of this tree here. So Mary compared their heights, which was very hard for me. Their heights are shown. Write and solve an equation. So I need to write an equation and solve it to find the height of the taller tree. So this tree is going to be H. We don't know it yet. And I need to figure this out. So there are a lot of ways we can write this equation. So I can say, right, H is the entire thing. H is the whole thing. And if I take away 12, so if I minus 12, then that should equal this tree that is 45. So I'm starting here. I'm taking this much away, and it's leaving me with the tree that's 45. I could write this a lot of other ways. That's just one way that you can do it. So now I need to get H all by itself. So the opposite of minus 12 is to add 12. So I'm going to add 12 to this side. I'm going to add 12 to this side. So this side right here, right, this cancels out. So I'm left with H equals 45 plus 12 will be my answer. But you have to have the equation you're going to use and then solve it. It does not just want to know what is that tree. It wants to see how would you set it up, and then it wants to show how would you balance the equation. You've got to do those things. Hey, number 5 asks me to write an equation. So with a solution of 25. So one side needs to be 25. So one side is 25. My variable is x, and I need to use addition. So I am going to say x plus, and then I can pick a lot of numbers to go here. But whatever x is, it's a positive number, and this is a positive number. So it has to be less than 25, right? If I put 40 here, whatever x is, it's positive because there's no negative sign in front of it. That would be bigger than 25. So that's not going to work. So what do you think you could put here? We don't even need to know what x is. You don't even have to solve it. You're just thinking, what could you put here that whatever x is would end up being 25? Hey, number 6 says that each small square on the scale is 1. So here's 1, 1, 1, 1. There's 2 ones over here. The larger squares are 10. And we've got this triangle that we do not know here. The scale is balanced. We have to find the weight of the triangle. So first it wants us to just write an equation. So over here we have 10, 20, 30, 1, 2, 3, 4. So the left side of the triangle is 34. And it's going to equal, we've got an x. And we're adding on, we know 10, 20, 21, 22. So we can see our constants are 34 and 22. And we're looking for the variable of x. So now it wants us to cross out same weights on each side until x is all alone. So what is the total weight you crossed out on each side? Okay, so if I remove this one, that will get rid of that one on that side. I'm going to remove this one, which gets rid of this one. I'm going to remove this one, which gets rid of this one. And this one gets rid of this one. So now I have x all alone, and I can see what is left on this side. So what is the total weight that I crossed out? So I crossed out 10, 20, 21, 22, right? This right here was 22. I crossed out 22 units on both sides there. So now what is the simplified equation represented? So 22 on this side. Oh, that's not 22. Sorry, 10, 11, 12. 12 on the left equals x on the right. Sorry, I thought I messed up left and right. I don't know that. Okay, so 12 equals x. I can see 12 here is x. which if we just solved the problem, right, I would get rid of 22 here. I'd get rid of 22 here. 12 equals x. So whether we're balancing it physically and taking them away or taking it away mathematically, we get the same answer. Hey, I'm going to do 2 more with you, and actually might be 7 if you follow along, or you can choose your own 7. Okay, so this one says to determine whether it is a solution, is or is not. So if I plug in 56 here, 56 minus 14, there's 2, and 4 equals 42, so that is a solution. That one made it true. Okay, and we've got 55. We're just solving the equation. 55 plus s equals 110. So I need to get s alone. So I have positive 55. So I want to take those away. What I do to one side, I have to do to the other, and I need to make sure I line up my numbers. Here's the ones, the tens, the hundreds. So this side cancels out. And then I'm going to let you go ahead and do 110 minus 55. Don't forget you cannot do 0 minus 5. Lots of us just like to bring that down without borrowing. So make sure you borrow on that, and be sure to always show your proof, or you're going to get them wrong, because I will not mark them right without your proof.